about a massive sinkhole developing due to the fact that it's just undermining the roadway there. And you can see that their firefighters are backed off, wait.
O helicóptero chegou em seguida e o que mais impressiona é que tem uma residência de 2 pisos, Gustavo, e que no primeiro momento até o teto estava em pé, logo em seguida, questão de minutos, tudo veio abaixo.
In downtown Pittsburgh, causing extensive flood damage and contamination of water. We are organizing ourselves to go at the site to do the inspection, corrosion risk assessment, and determine the primary cause of the failure. Our objective will be to document the site, identify if the soil is corrosive and has caused the failure, or is it the stray current. Our team is getting organized to leave in next few minutes.
This is the broken segment of the water pipe. From the appearance it looks like cast iron, and you can clearly see the thickness. This is the actual thickness of the sample, and here you can see the reduced thickness, and here where the tape is pointing you can see the indications of graphitization.
Exhibits signs of graphitization. And more than 50% of the thickness in the fractured area is graphitized. That's why we have the failure. Please make a note here. That's great. Thank you.
Once the soil samples reach the soil lab, we're going to look at the corrosive parameters. We're going to look at resistivity, saturated resistivity, corrosion rate, as well as the chemical properties, chlorides, sulfates, sulfides, pH, and redox potential. When we have this data, we put it together with our field inspection, and we're going to do a corrosion risk assessment. Here you can see we've done a corrosion risk assessment with an area in the United States where we were able to take the parameters that we look at in the soil lab and put them together to identify areas of high risk.
Hello, my name is Ed Larkin. I'm the Technical Director for Matergenics. We're in the Matergenics laboratory in Pittsburgh, Pennsylvania. We have here a section of a gray cast iron water pipe. It's approximately 90 to 100 years old. It failed catastrophically, releasing a large amount of water, which caused damage to the street and the cars parked on it. The fracture surface is here, and you can see there's a difference in the structure between this light gray area on the inside diameter and a darker area on the outside diameter. The darker area represents graphitic corrosion. This is a corrosion process where the gray cast iron consists of graphite in an iron matrix. When corrosion occurs, the graphite flakes keep the iron corrosion products in place. Therefore, the pipe appears to be sound when looked at from the outside, but in fact the wall thickness is greatly reduced. This overall fracture is known as a window failure, when a large section of pipe comes out, releasing a large amount of water through this space. Other types of failure for cast iron could be transverse cracking, longitudinal cracking, or small diameter holes from corrosion. This is the most catastrophic form of failure for a cast iron pipe. So what Matergenics will do, Matergenics will make cross sections to look for the microstructure of the pipe. Being 90 to 100 years old, these pipes were cast differently than modern pipes. Modern pipes are usually centrifugally cast. However, 100 years ago, they were generally statically cast in a vertical direction. Because of the materials and the processes, the microstructure and properties of these pipes can vary. Therefore, we will look to see if there's anything in the metallurgical structure or microstructure of the cast iron pipe that could contribute to brittleness and failure after this much of the wall thickness is lost due to corrosion.
Okay, Dr. Z, let's review this project. We got a call from our client and quickly responded. It was a break of a water main, 36-inch main in Pittsburgh. Got our team together, went down to it. We took indirect assessment, direct assessment. This being the key piece. We also got soil samples, brought them back to the lab.
From here on, our task is to identify the primary cause and the root cause for failure. Is it the material? Is it the soil? Is it the stray current? Or is it the design? We will do metallurgical evaluation, corrosion evaluation, and we will identify the primary cause and root cause of the failure. We will draft and document everything we have done. We will send it to our client for their review.